quickly move on towards the next session where we are going to have a presentation on success factors in smart metering projects. And we have Mr. Rene Boringer, the co-founder and managing director of CUCULUS, a leading edge German software company that develops and delivers HES, MDC, and MDM solutions for the utility sector worldwide. Mr. Rene is an industry-leading expert in the field of smart metering and specialized in the world of energy. Hi, sir. Can you please unmute? Mr. Rene, can you please unmute?
Okay, I'll unmute.
Now it was overlapping, sorry. I was unmuting myself and got unmuted as well, which is a mute again. So 1 + 1 = 0.
So all set, all the best for the session.
Thank you much. I hope you can see my slides.
I can see the screen. Yeah.
Thank you much. So welcome to this session. It's a little bit different one, I guess, than what you have heard before. I try to limit the technology, even I have some technology inside. So I'm Rene Böhringer, I'm the founder of CUCULUS. I'm in the area of utilities and especially in the area of smart metering projects, smart grid projects and IoT projects. Even at this point in time, nobody called it IoT since approximately 15 years. I'm doing projects all over the world. We have actually gathered approximately 100 specialists working for us, with us together and with our customers and with our partners in these projects. And what I want to bring today are some lessons learned out of these plenty of projects we are doing in Europe, in Asia, in Africa, and in other regions of the world. And you will be surprised, it's probably completely different than from what you're expecting now. What do we do as CUCULUS? So the first thing is that we have a big vision, and this vision is that we want to enable affordable energy and water for everyone, everywhere in the world. Of course, we have very limited capabilities to do that, so we do our best on where we are actually specialists in, and that is the software sector. So we are developing solutions, and I'm explicitly say solutions, not only software, for only that one sector. So our investors always call us niche players. So we are playing in this small niche of utilities. Even I don't agree that this is a very small niche. I think that is one of the most interesting, most innovative market areas in the world across everything, and that changed. We will come back to that later. So we are developing cutting-edge software and solutions to deliver different kinds of applications in the utility sector. As I already said, we are focusing on solutions. If we have learned one thing in the last 15 years, it's not about a tool. It's not about a communication technology. It's not about a specific meter. It's about a solution which should work end-to-end. I always call that end-to-end business process. So it's always the processes first, the use cases first, and then all that small technology bits and pieces are coming together and need to serve that overall process. So we have not seen a single project which was successful, which was not seeing the whole thing from a use case, from an end-to-end process perspective. For that one, you need, of course, partners. You need to have your customer involved to understand the requirements, to guide, to handhold all the vendors, all the different players in the game. What is completely different to the past is that we have now a kind of a chained system. So if the meters are not working, it will not work. If the communication is not working, even the meters are perfect and the software is perfect, it will not work. If the software is not working, then also the overall use case cannot be fulfilled. The utility gets nothing out of the investment. And these are only 3 big components. There are many more actually involved in that game. About what I'm talking is actually the 3 application cases which we are enabling, let's say, to enable also the future of the energy sector. On the one hand side, this is smart metering. Smart metering for us is residential metering, but also industrial metering, classical CNI metering, but also advanced distribution management or automatic distribution management, which is actually very close to the CNI metering. It's just mapping approaches of the residential metering into the area where we have seen SCADAs before. On the other side, we are also targeting on smart grid applications. So smart grid for us is something which is mainly actually dealing with consumers and producers. So prosumers also, so it's actually matching the demand with the response in the grid, doing analytics across different utilities. And when we are talking about smart grid, it's also something where we definitely see a full integration of different utilities. So it means actually electricity, water, gas, because in nowadays world, everything is interchanging. So in the past, actually, we heated a lot with gas, for example. Nowadays, we are heating with a little bit of gas, but we are also involving heat pumps, which is actually translating our gas consumption into electricity consumption and vice versa. So if we want to have low temperature heating networks, then we need to heat up the water for example, let's say classical hand washing, dishwashing with electrical water heaters. So that is also something where we see an exchange between the utilities. And last but not least, there's also the section of the revenue protection. So how to get the money in, where we need the basis from the smart metering or smart grid environment or infrastructure to read data, to make it possible to have things like prepayment, but prepayment without paying, I would say. So it means actually that's a fully automatic system which allows you to, on the one hand side, run very complex prepayment processes, but also do everything automatic so that people do not need to enter 20 digits token into their meters. And that goes up to post-payment, but also settlement processes. Settlement is the allocation of the different, for example, loss factors or cost factors in a grid between different market players. And all of that we do with just one single system, which is our Sonos IoT platform. We have just heard a question, how is IoT involving or impacting the smart metering sector? There is no difference. So smart metering, the smart metering application is the biggest application for IoT in the world. There is nothing bigger than that. The second one is actually the automobile industry, which is also using IoT as a solution. The only thing what is different is we're using different types of protocols and we have different types of standards and regulation in our area. But the classical characteristics of an IoT network is that we have to connect plenty of different types of devices into the same network, that we have to deal with a tremendous amount of data in our networks and in our storages, and that we have the vision that we can do something big and applications on analytics with this data, but we actually don't know what it is right now and what it can unfold. So what we do is we provide all that flexibility on our IoT platform to connect different types of meters, different types of communication technologies, and gather all of that in our head-end system, or MDC, you would call that. We call it AMM, Advanced Meter Management, and then we forward it to the MDM solution and to the business connectors. So what I show here is the whole chain again. Even the meters, the communication is not shown in between the meters and the head-end system, then the software solutions, and also, of course, what we call the legacy systems, like the billing, the SCADA, the outage management, the GRS system, and so on. So always the whole chain must work, as I have said. So that we are doing with, of course, with a big group of people. We think that these people is the real treasure. I will also come to that point back a little bit later on. So we think that delivering this kind of project is only possible if you have people who want to listen, who want to understand the particular circumstances in the area where we're delivering projects, who are speaking simply the language of our customer, and who are able to connect deeply with our partners and the utilities we are working for. So our team is approximately 100 people out of 21 nations speaking 38 languages. Coming to the lessons learned. So what we see here is Michael Schumacher. I think everybody knows him. That is the most successful racing car driver in the world. It was a German one. And this guy is sitting in an Italian car. So sorry for all the Italians listening in, but I think the Italian car here is not per se labeled as the winner, or was actually seen as the winner. It was a car which was not really well performing, actually really worse performing, totally outperformed by Mercedes-Benz at this time. But anyhow, how these guys made it to win the races, to dominate the whole scene over many years, so that even some of the players thought about giving up because there's no chance to beat these guys. It was actually something which is a game of 3 different players. So that's the car, of course, that is the driver, and that is the management team. Thinking about smart metering project is the same. So we have actually a car, which is the overall solution. We have a driver, which is, from my perspective, the utility. And we have a whole team around it, which should make it happen, which are the vendors that make working for winning the race. So it needs a very tight work together to make things happen and to win it. So you can even win the race if you have not the best car. It's about having the best team around it. I will next show you some of the, let's say, basic statements I normally see and hear in the different markets, from the different markets players, which are for me indicators that the project will fail. I have never seen a project which was failing because of technology. I have never seen a project which was failing because of the wrong meter, or because of the wrong software solution, or because of the wrong performance of the operation. I have seen projects failing because the people who selected the technology were not into the right skill set and knowledge level, were not open enough to discuss with people. I've seen projects failing because everybody did, in a kind of a silo approach, his own parts of the project without talking to each other. I've seen projects failing where we had the classical relationship of somebody who is the buyer and somebody who is the vendor, and these people only talk via contracts with each other. I have to say, we are building here a very complex solution, and that requires communication, maybe also an agile approach to address the whole thing. But it's definitely totally different than it was in the past. At the time when I studied electrical engineering more than 20 years ago, nobody wanted to go in the specialization of the grid, of the high voltage electrical engineering. It was the most boring subject at all because nothing moved since the last 50 years. So compared to this one here, we were building lorries as we have built them 50 years ago. So it's actually just repeating what the guy before you have done. But now, 20 years later, we are building racing cars. We are building racing cars, the most complex thing what you can find at this moment on the globe. So that means you will never buy the perfect solution. Never. So if you think you can do some pilots and then you will have the right solution, that will not happen. First of all, we are designing solutions today, we are investing today, we are spending that cost today, but actually that investment should last for the next at least 10, 15, maybe 20 years even. Do you know which kind of application we will face in the next 20 years? Just have a look back where we have been 20 years ago. As I said, so we were building lorries. Now we're building racing cars. So what is the next step? We will maybe build, I don't know, starships or something like that. So think about designing really a flexible system which can be extended, where you can reuse components in your solution. But flexibility is the key when it comes to the solution. So it's more buying in the flexibility for the future than the perfect solution right now. Back to the racing cars. So of course you can decide actually to race with the same tires even it starts raining. But it's your decision. If you think you can win, it's just a short time to race with a dry condition tires, then you can do it. But if you think it should be better to change to raining tires, then you should be able to do that. So your car should have the possibilities to change the tires according to the weather condition, because you don't know if it will rain or not. And you don't know what the strategy of the other ones in the race will be. So you need to be flexible to adapt yourself. So it's better to make sure that you can change the tires. And maybe changing the tires is something which is very complex. So the process cannot be handled. So you do not need to only change the tires. You need to make the whole wheel exchangeable, because that is fast. That you can do within a couple of seconds. Think about what that could mean to your smart metering project. I have never seen, never so far, any project in the world which can just live with one communication technology. We have actually a big customer in Middle East. Actually, I can say, so it's a project in Dubai, one of our lighthouse projects, where we are metering the whole wet water network of the state. So this is about 1 million flats where we are reading this data every 15 minutes. There was a lot of pilots upfront, which actually identified one communication solution, which was a fiber-connected gateway, which has cables to the meters on each floor of the building. So that was actually the output of all their pilots. They started with that one, and after a very short time, they found out, oh, there are villa areas where this cannot be applied. So I need to have another technology to hold the schedule of my rollout of meters. So they wanted to be very fast. And that means they had to use an RF technology where they put an antenna in the middle of this villa area to connect their meters, because cabling all of them would be too expensive. They cannot get the permission to drill through the fences and through the walls of the buildings from the owners. Later on, they found out, oh, there are also some tanks under the buildings, which I can really reach hardly with my RF mesh. So I need to use, also not with mobile communication, I need to use something like LoRa to drill in under the ground and connect that meters there. And finally, a handful of meters were left, which could only be addressed efficiently with mobile communication. It were meters on the desalination plants out in the sea where you have mobile connection, but nothing else. So suddenly they were faced with 4 different technologies, communication technologies to connect their meters to have 100% of the population connected. So they were lucky because they were prepared, they were flexible enough to connect all of that into the same system without designing everything and building new integrations and all this stuff. So the flexibility was key for them. It's also wrong that you can imagine or you can assume that it works for you if it works for others. We have actually totally different environments everywhere. Of course, you know that. So sometimes we are faced with grids which are not the most modern ones, so PLC is already out of the game. Sometimes we have extremely high densities of meters, so also issue for RF mesh or any kind of RF technology. Sometimes we have actually very widespread areas where there's no mobile communication, so mobile is also out. So just looking at other countries or other projects which have done something like that in the past, it does not mean it will necessarily work in your area. And sometimes the differences are small. So here again, I'm showing the Burj Khalifa. That was at this point in time the highest building in the world. So the company who built that, of course, should be very knowledgeable in building very high buildings. But if you want to do that in a seismic area where you have to deal with earthquakes all the time, does it mean that these guys can build the same height of the building? No. So you might need to have specialists who are used to build buildings in such an environment, not in the flat desert where nothing happens like that. So the people who are executing and doing the project, they should really understand the circumstances. Back to the racing cars. So here it's also the same thing. So you can have the driver and the team and the car, but if the car does not fit to the team and the driver, this can be the best car in the world, but it will not work. So the proof is here also that putting a winning driver into another car will be a complete setback. Also, Michael Schumacher experienced that when he changed from Benetton to Ferrari. So he was already the champion, winning the races, went to another team with another technology, which was also a car which was playing in the race, but both together would not work. One of the most heard sentences is, okay, we are only the users. We are just the users of it. So you should make it work for us. So here I have to say that's a clear no. So that is the solution for the utility. That is the solution for you. So nobody knows better than you how it works. Of course, everything is new. So we are not riding the lorry anymore. We want to race the car. We want to race a very fast car. So it's better to have also the right people on board who are driving that cars, and they should give the input. The same in the racing industry. So the people around Schumacher's team are the best engineers in the world, I guess. So they are specialists in whatever they do, but they are not driving the car. They can optimize it, they can measure it, but they cannot feel it. They cannot feel how this car behaves when it's slippery, and if this is just on the border for the need to change the tire or not. That will be the instruction by the driver. On top of that, our experience is that the most people cannot express the obvious. So what is completely normal for you in your daily job, I don't know, you know on one, let's say with one dashboard, what's going on in your environment. That is not obvious to the one who is delivering you the solution. So they are specialists in building their solutions, but they're not specialists in operating them. And how you operate it, that is highly dependent on your style of driving the whole thing. All right, so sometimes we have more the aggressive driver who needs a totally different car and a different technology. And sometimes we have more the one who is going steadily with a high speed, but very carefully, and he avoids accidents. And with this one, he's winning the race. So that needs to be exchanged. You are still the driver of the solution, and without you, it will not work. You cannot set back like the driver would come from the race, say, okay, please team, make the car faster, go back home, sleep a while, and next morning he has a faster car. That will not work. The driver needs to be in the garage, working the whole night with the team, with the vendors to make the best technology, the best car, to make sure that the next day it's really faster. Another thing is a little bit to also to the internal organization of that projects. So we have seen many projects, and we still see projects which are operated by the IT department in a utility. Of course, they need to support that, and they are the best and the most knowledgeable people around IT technology in a utility. But the IT is only a small part of it. And just to be clear, I think that is even an improvement. 15 years ago, all the smart metering projects started with the metering department. Nothing against the metering department, but people working in the metering department have a totally different skill set and mindset also of issue tackling and problems. They are coming, from my perspective, more out of the automation industry, whereby smart metering solutions coming more out of the communication technology side. So I think it's already an improvement to have it in the IT department. But this is the same internal as with external vendors. So the IT department does not know necessarily what's going on the operational side. I just want to give you here an example of another a project where we were actually pushed to provide 15-minute values in real time, all the time, with 100% success rate. So that project we're going on through approximately 9 months. We were all investing a lot of time to make that happen. And finally, we presented the solution to the team. And now, first time, there was also the team sitting in there operating the solution. So the 15-minute came actually as a requirement to avoid that people have to wait very long time when they sit in the help desk center of the utility and complain about their bill. So the idea was to press a button, immediately go down, read the meter very, very fast within actually a few seconds, and then tell the client if his bill is correct or not. In this very famous meeting, the guys from the help desk said, okay, this is nice, but who asked for that? Nobody needs that, because in our process, we have to write a ticket. And the ticket will be processed in a batch process overnight, and we will answer the customer later on via a call or via an email. So there were fortunes, hundreds, thousands, if not millions US dollars spent to build something into a solution which was actually not needed, just made all the things more complicated and harder to manage. I do not say that 15-minute values are useless, but in this example, the driver for implementing that was completely wrong. Another issue we have is that we still have an underestimation of security issues in such projects. Of course, everybody is asking for security. We are coming back again to the issue of, let's say, the involvement of only IT people in that one. So if it's about security, we often just discuss about the encryption of the communication from the meter to the head-end system. Nearly no attack comes through the meter to the head-end system. The majority of the attacks, and then I'm not talking about maturity more than 50%. I'm more talking about 90% plus is coming from the inside of the systems. So this is a process. It is a people's issue. So it's of course much more comfortable for somebody who wants to do something bad in a solution to just apply for a job and get hired by the utility than to spend a lot of time to hack into one single meter communication and to get stuck in the head-end system where you can anyhow not do a lot of things. So the IT security is a very small part of the whole game. There is a lot more around it, and you have to have security by design, otherwise you will lose out. So in the racing car, if you find out, okay, it's maybe better to have some fire protection because just yesterday a car of your competitor burned, it's impossible to build a fire protection around your stream optimized car chassis, it will just not work. You even don't need to start anymore. It will protect you from the fire, but it will also protect you from participating in the race. So you have to have that built into the system from the first day onwards. And last but not least in this one, you have to deal with zero-day attacks. So it means you have to have a mindset which says you don't know what will happen. There is not a fully secure system. It will never be fully secure because you're just one day ahead of somebody who find out how to hack the system. So you need to deal with that one. You need to face it. You need to have processes in place to avoid that and to limit the impact of such attacks. Then trying to invest everything to avoid them. It's impossible. The very last point before I come to the conclusion page here is that such systems need maintenance. I have rarely seen projects where people deal with the process of continuous improvement, adaptations of requirements, handling security issues. Now, maintenance of a solution is seen as a very small portion, what I just put as a requirement, and in the best case, as a warranty requirement into tenders. I just want to tell you that according to our experience, 100% of the cost you have to add to your project during the next 8 to 10 years just for maintaining it. If you do a bad job in the project design, in the solution design, that will even be more. So whatever you're investing right now, including meters, including installation cost, you will spend later on. If you do it in the wrong way, you will spend even more money later on to fix the issues, or you cannot address new opportunities because the system is now limiting you instead of enabling you. So the maintenance and support should be an integral part of it. It should not be seen as a must-have, which I just do with the least cost. No, that is the thing which keeps you actually in the race and keeps the car fit to win the race. And of course, you have to optimize it because you don't know what will be the change of tomorrow. Maybe it's a regulatory thing, you can do nothing, but you have to adapt to it. And if the adaptation cost is too high, actually you're locking out yourself. So to summarize a little bit, again, I called it here the 8 brutal facts I have tried to put on that last slide. The first thing, if you are aware of that facts and you implement that into your way of thinking and into this design of projects and into your decision-making process, then you will succeed with your projects. So the first one is, you have never done it before. Most of the players have not done it before. So they have maybe done small pilots, but not such a thing. So just a few years ago, when we also talked about, let's say, giving the lead of such a project to an IT department, I was using the comparison to the New York Stock Exchange. So you're designing a system from scratch, which has the load in terms of the amount of messages it needs to process of the New York Stock Exchange. And that you do with somebody who has done something completely different before, maintained a SCADA system or the internal IT network. So that will not work. It's also not your core competence. So your core competence is somewhere else. You are more on the OT side than on the IT side. This is your communication on the edge of communication technology, electrical engineering. It's a field of melting things. So make sure that you get the competences on board. You cannot rely on others because you need it. It's not a one-time thing. You will be the whole time on a journey to improve the system, as we have heard before. You need to definitely to adapt your processes. So all that smart metering, all that smart grid initiatives, they will not work if you just think this will replace the physical process before. Our investor E.ON, which is the biggest utility in Europe, 30 million customers. Of course, it's not so big compared to your utilities in India, but it is a really big one in Europe. They did an analysis and they found out that they have approximately 900 processes in their organization. And out of these 900 processes, 870 processes are impacted when introducing smart metering. That starts from selecting the right people, changing the purchasing processes, changing operational processes, what kind of tariffs you can do with the customer, how you do your maintenance jobs, how you design your help desk. Everything is involved. That's a tremendous change, but also a tremendous chance to change things. But there needs to be change management involved. Number 4 is nothing is for free. So it doesn't matter when, but you will definitely pay the price. So sometimes the initial project will be cheap, but you pay a fortune afterwards to maintain it, as we have heard before. Sometimes you get a piece of software, maybe as a little gift from somebody else, but later on you pay that on a higher price for components. You get a license cheaper, but you have to pay it for implementation costs. So please always take the total cost of ownership into consideration, which also includes the next 15 years of operating it and adapting it and addressing it to new opportunities. Number 5, you cannot avoid it. You cannot just wait and it will go away. It's there, it will come, and nobody can stop it. So sooner or later you have to face it. So better do it now with open eyes than just waiting somebody is pushing you into it. And this is, of course, again, it's a mindset thing. Are you doing that to win a race, or are you doing that because somebody just put you in the car and say, okay, go? You cannot kill that with more specifications. This is the most complex thing you have done before, compared to what you have done before. So we still see the hope that some standards, like, for example, your IS 5959 SIM standard for the communication between systems, will solve the problem, and you can just plug and play things together. It will not work. You always have to adapt, even on the interface level, it will not work, it will not attach together. But also, especially on the process level, it will not work since end-to-end process will not run through smoothly. So you have to deal actually with a certain agility, try it out, do the first step, test it and improve it. And that's also what helps for the point number 7. You have to deal with uncertainty. This uncertainty will not go away. You don't know what will happen in the next years. And as soon as you finish a testing round, you get a new idea what also can be tested or what also can be implemented. And then you want to test it, and you're changing your requirements, and you're continuously unsatisfied because you will always run with your project after your new ideas and your new opportunities. Please understand that as a positive thing, because the systems, it means the systems is enabling you. It is possible to do that. Just try to manage it, and don't think that the system is too old and cannot deliver it. If it's flexible enough, it will do it. And the last point is, even you did everything, all the 1 to 7 points before, at the end, it will still be different than what you thought and what we thought. It's a very interesting area, and that actually creates the fun for us to work into this area. So we think that all of that we can only address if we have some hand-in-hand strategies. We go together with our partners, with our customers, with other market players to solve that challenges in the industry, and to create the racing cars and to win the races with the best cars and the best teams and the best drivers ever. That is what we do. Thanks a lot for listening in, and now I'm open for your questions.
Hi. There are a few questions for you.
Yeah.
All right. The first question is, how do you see smart meters in the integration of renewables?
So renewables is one of the most important drivers for smart metering in certain areas of the world, especially in Europe. So we see extremely high fluctuations of demand and response, especially, of course, here of response. So actually the fluctuation of the energy available in the network needs to be managed, which can only be done by managing the demand. And therefore, this smart meter is absolutely essential. So we nowadays, for example, in Germany, at certain times over the day, we are producing more energy than what we can actually use. So renewable energy is destabilizing our grid. And the only medicine against it is smart meters and controllable consumers.
The next question is, what are CUCULUS solutions for utilities approach to data analytics and management?
Yeah, so data analytics is a big buzzword, and it's not going automatically. So it always needs to have assistance, and so also that is one of the big areas where you also always have to expect changes due to what you learn, but also due to the external circumstances. For example, the introduction of massive plans for renewable energies will change all your measures. We do things like, let's say, our whole focus is to integrate that flexibility. I want to give you an example. So a huge role plays actually forecasting. Forecasting of energy production, but also forecasting of energy consumption. And in the past, this kind of forecasting actually required high specialized teams and algorithms which need to be tuned over a very long time, and then they are delivering good results. So our focus was not to improve the results of that algorithms. Our thing was to deal with the flexibility and to deal with the unknown thing in the market. So, for example, to be able to deal with the changing patterns of renewable energy in the grid, to deal with things like pandemic situations where the algorithm is automatically adapting to this scenario. The most of the algorithms in Europe and Asia failed when people totally changed their behavior and just stayed home. So flexibility and easy to use algorithms, that is our focus. Not the most sophisticated ones, because that nobody can use.
All right. One last question. What are your prospects considering both current and future challenges in the smart metering? What are your prospects considered to this?
You mean what is the bigger thing, what I see ahead of us?
What are your prospects considering both current and future challenges in the smart metering?
Okay, maybe I don't understand what exactly should be addressed with prospects, if that is customers or projects or the challenges. I will just answer with a challenge. Okay. So what we see at the moment is that I mean, there is a huge change process, and that is what I wanted to try to address here, which is not only technology. Technology is completely useless if it's not in an environment which is able to absorb and to adapt to that change. One of the bigger thing is to introduce the idea of IoT into the utility sector, which for us means actually breaking the silos of very specific application for EV charging, for renewable energies, for innovative heating and cooking solutions, for cooling solutions for example, in Africa and Middle East, and put them together on one single system, so that it is possible to change and to manage actually between that solutions and use heating systems to store energy if there is too much, or to use the car to consume energy if there's too much, but also to deliver energy back. So breaking the silos and making that this application transparent and connected to each other is, from our perspective, the biggest challenge and the most interesting challenge in the sector at the moment.
There are a few more questions. The next question is, how CUCULUS MDM is compared to existing MDMs in India when it comes to flexibility, integration, and the cost?
Of course, I mean, we are vendor. Our system is the fastest one, the most flexible one, and also the cheapest one if you use it in the right way. Right? That is the answer. That's the marketing answer. We of course there are different market players, and we are 100% sure that no one has the perfect system for all circumstances. I mean, this is what I try to explain here. So you have to find the right racing car for your organization and for your problem. So if that is something where you need hand-holding, you need to have people who are doing that project with you together in a friendly and partnership manner, who are flexible enough with their team to change actually to your requirements, because we are owning the full source code and our team is actually 100% on that one solution, then CUCULUS is the right one.
One last question, gentlemen. The last question is, please provide any use cases in accordance with service level agreements.
Oh, that is one of my most beloved topics. So service level agreements actually is something which from our perspective should less be IoT driven. So I still see in tenders that people asking for 99% availability of servers. This is completely wrong. Nobody cares. So this is from our perspective more an OT system. So you have to make sure that your use case is working, that your people sitting in the help desk get the right information, that the people who are out there and doing an installation, getting their processes done, getting their messages processed so that they have an instantaneous feedback that this meter is installed correctly. The billing process as such, which is often the core for that SLAs, is actually something which is in the most of the countries extremely relaxed, because nobody is billing every 50 minutes. But it's immediately changing, of course, as soon as you're connecting displays of users, apps of end users to the whole game, where this user can see 15-minute value in his app. If this is not working in the next 15 minutes, you have a lot of service calls or help desk call where people say, hey, something is wrong, your accounting is not working, I will not pay my bill. So that is actually where the cost is coming up. And that needs to be managed. So we actually propose use case-based SLAs to make sure that always your operation of the solution works. And when it comes to overall, let's say, fulfilling the SLAs, then the speciality of CUCULUS is that we still see ourselves as an engineering company. So we are considering the process end to end. We are considering meters, communication networks, the head-end systems in front of us, or we are the head-end system, and then also up to the MDM. So whatever we can do, for example, to avoid an overload of the network, just because the MDM system would do what we call a gap closing, just trying to read missing meter reads at the end of the month or beginning of the first day of the month. If we know that this would overload an NB-IoT network, or it would totally kill an RF mesh network, then we will not do that and spread that request over a certain time, because we know the behavior of the systems in front of us, and we are optimizing our software so that it uses this knowledge to ensure that the SLAs can be met.
Well, thank you, gentlemen. Thank you so much. I think we are done with the questions, and
it was a pleasure.
Remaining questions we are going to send you through your email.
Thank you. I'm looking forward to that. Thank you for having me.
Thank you.